Look at this star. It lies at the heart of its system and makes up 99.8% of its mass. It's a relatively young star and part of a generation of stars known as Population 1. Yep, there's an older star generation called Population 2, and an even older, and not even proven, Population 3. Anyway, this star was born around 4.6 billion years ago. It most likely formed from a giant, rotating cloud of dust and gas. Such clouds of space matter are called nebulas. One day, the nebula started spinning faster and faster because of the force of its own gravity, and then it flattened into a disk, and most of the material got pulled towards the center, forming a star. But it's all in the past. Right now, you see a ginormous comet flying towards the star. Are they going to collide? Well, it's time to reveal all secrets. The star I'm talking about is our Sun, and the comet approaching it at a breakneck speed is 96p Machholz 1. The comet is around 3.7 miles wide. Astronomers think it might have arrived from outside the solar system. The NASA ESA Solar and Heliospheric Observatory spacecraft is monitoring the comet as it's dashing towards our star. Right now, it's moving inside Mercury's orbit, leaving an icy trail as it's nearing the Sun. Now, look at this. That's the comet's trail. It's mostly made up of gas. It's trickling behind the frozen chunks of ice that are getting heated by the radiation coming from the Sun. In some cases, a comet can have two tails, one made of dust and the other consisting of gas. And each of them can reach hundreds and, in some extreme situations, even millions of miles in length. In 2008, scientists analyzed the material left by 150 comets. They found out that the comet we're talking about was quite low in carbon and didn't contain a large enough amount of some other typical materials. This could only mean one thing. The comet was an interloper coming from another star system. It may have been ejected from its original solar system by the gravity of a large planet. After that, the poor homeless celestial body probably spent a large amount of time wandering space, until it came across Jupiter. The gas giant could have bent the comet's trajectory, trapping it in orbit around the Sun. There's one more theory. According to it, the comet formed in a poorly studied region of the solar system, and it has this weird composition due to its repeated journeys around the Sun. Now, scientists are watching the comet with bated breath. They're sure that once it collides with the Sun, they'll be able to learn new information about this space wanderer. And since the comet is an atypical one, both in its behavior and composition, they don't know what they will see, which makes the whole process even more exciting. David Machholz, yes, that's the one who the comet was named after, first noticed this space body in 1986 with the help of a homemade cardboard telescope. The most surprising thing about this discovery is that most comets falling towards the Sun are quite small, not more than 32 feet across. That's why they burn up as soon as they come close to the Sun. But the sheer size of Machholz 1, which is more than 2/3 the height of Mount Everest, seems to protect the comet from evaporating completely. The SOHO has already recorded the comet making 5 close passes around the Sun. The most recent one happened on January 31st, 2023. The giant comet was 3 times closer to the Sun than Mercury. But what would happen if a space body like this one crashed into our star? There is a special name for comets that come too close to the Sun: sun-grazers. They can pass a few thousand miles away from the star's surface. At the same time, we know that the Sun doesn't have a surface. It's a giant ball of immensely hot gases, mostly hydrogen. Comets that get too close to the star can pass through its Roche limit. After this border, space travelers usually get ripped apart by incredibly strong gravitational forces, or at least that's what happens to small or structurally weak comets. But our comet is neither weak nor small. It can potentially survive the Sun's gravity and cross the Roche limit again, leaving the dangerous zone. But such comets have other problems. because solar radiation and heat are powerful enough to crack rocks. So, imagine 96P Machholz 1 speeding towards the Sun. It's moving faster and faster, crossing the Roche limit. And it looks as if it's not gonna stop. Soon, it's dashing at a speed of 370 miles per second. And then, boom! The comet gets flattened by the Sun's atmosphere. This generates a truly spectacular explosion. It throws out countless tidal waves of X-rays and ultraviolet radiation. This explosion unleashes as much energy as a coronal mass ejection or a powerful magnetic flare. The momentum makes the Sun ring like a bell. Then, a series of sunquakes echo through the solar atmosphere. And that's what might happen if a massive comet crashes into our star. Scientists admit that their theories are just speculations. For one thing, a sun-hitting comet hasn't been seen yet. Plus, no one is sure what physics will determine its fate. Astronomers know about comets that came pretty close to the Sun and survived this feat. For example, in 2011, it was a comet named Lovejoy. It passed through the corona, the outermost part of the Sun's atmosphere, usually hidden by the blindingly bright light of the surface of our star. When the comet emerged, it was much worse to wear, that's true, but it was still intact. Another comet that survived this dangerous approach, though barely, was Ison, and it happened in 2014. So, what does a comet need to reach the Sun's lower atmosphere? A mass of more than 1 million tons. This lower limit is about 100 times smaller than comets Lovejoy and Ison. There are long-period comets that take more than 200 years to orbit the Sun. Scientists think they might originate in the Oort cloud. It's the most distant region of the solar system, its outskirts, so to speak. It's a collection of icy objects farther away from us than anything else in the solar system. It lies at a distance between 2,000 and 100,000 astronomical units away from the Sun, and 1 AU is around 93 million miles. This region is also described as a cometary reservoir. No wonder, according to some estimates, there are more than 1 trillion icy objects there. So, some of them are bound to wander off, right? You can also find an estimated trillion or even more comets in the Kuiper belt. This region lies beyond the orbit of Neptune. It's a donut-shaped ring of icy objects surrounding the Sun, 30 to 55 AU from our star. Short-period comets that take less than 200 years to orbit the Sun appear there. The first mission to explore this distant region was New Horizons. Right now, it remains deep in the Kuiper belt, speeding away from Earth at a rate of about 300 million miles per year. There are also dwarf planets dwelling inside the Kuiper belt. Some of them have their own moons, and this egg-shaped planet, Oumuamua, even has a ring of its own. By the way, a dwarf planet's atmosphere can collapse if its orbit takes it far away from the Sun. A bonus fact, even though you might not have noticed it, we live inside the Sun. No, I didn't mean that we literally inhabit the star that is 93 million miles away. The thing is, the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, exactly the gust of solar winds create such a breathtaking phenomenon as the northern and southern lights.
Asteroids are a serious, very real danger. Some of them are big enough to cause a lot of trouble if they collide with Earth. One asteroid in particular is making headlines these days. A new study has revealed there's a small chance it could hit our planet during its close flyby in 2029. But the question is unusual. Will the asteroid survive this encounter? Apophis, which got its name from Apep, the Egyptian deity of chaos and disorder, has become one of the most infamous asteroids. Discovered in 2004, this space object is about 1,100 feet wide. It's about the height of the Eiffel Tower in Paris. Because of its size and the close flyby predicted for 2029, astronomers classify Apophis as a potentially hazardous object. Those are asteroids and other space objects that pass close to Earth and are big enough that we really need to pay attention to them. Right now, scientists say the chances of a collision are slim, less than 1 in a billion. So, at the moment, we can probably claim that Earth is out of danger. But the same can't be said about the asteroid itself. When Apophis passes close to Earth in 2029, our planet's gravity is likely to shake it so violently that it may experience something like an earthquake, a cosmic asteroid quake, if you will. The stress from this gravitational force will probably cause parts of the asteroid's surface to crack off and fly into space. And even though this might not be a full-blown disaster, and the asteroid won't fall apart completely, it's very likely to lose some material during the flyby. Some of this debris might just stick around in orbit, while other bits could fly off into deep space. Over time, this catastrophe could affect Apophis's rotation, causing it to spin differently or tilt in a way it hasn't before. And this is a phenomenon scientists are really interested in, because it could teach us a lot about how asteroids react when powerful gravity is pulling on them. Now, let's get back to Earth. Well, we haven't left. Anyway, even though the asteroid isn't big enough to wipe out the planet like the asteroid that destroyed the dinosaurs, it's large enough to cause serious damage to a large city if it ever collided with Earth. It could mess with the climate all over the planet, too. At the moment, it looks like the space rock will sail past Earth at a distance of around 20,000 miles. It's still worryingly close, but far enough to avoid a collision. To put it in perspective, that's less than a tenth of the distance between Earth and the Moon. So while Apophis likely won't hit us, this flyby could still cause problems for some of the satellites orbiting Earth. They will be much closer to Apophis than we are. The key point is that we can't rule out a risk of a collision in a few more years. As Apophis gets closer, astronomers will keep a very close eye on its trajectory to make sure it doesn't veer off course due to the influence of Earth's gravity. In fact, this gravitational pull could actually cause some serious changes to the asteroid itself. Now, even though Apophis is not likely to cause a global disaster if it were to hit Earth, the consequences would still be pretty severe. The impact could destroy an entire city, and the resulting climate changes could mess with food production for years. It wouldn't be an extinction-level event, but it would still be a huge deal. Now, Apophis is not the only asteroid we need to worry about. Scientists are constantly on the lookout for other asteroids that could potentially cause harm to our planet. Thanks to new technology, astronomers can now track dangerous space rocks from way farther out in space. One cool new method they're using involves studying meteor showers. These showers are actually caused by long-period comets that have been orbiting the Sun for hundreds or even thousands of years. As these comets pass by, they leave a trail of dust and debris, which can end up creating meteor showers when Earth passes through them. Scientists analyze the properties of meteor showers, like their speed, direction, and where they come from. This can help them trace the particles back to their parent comet or asteroid. It's actually a big deal, because it means we might be able to spot potentially hazardous asteroids long before they get close to Earth. The upcoming Legacy Survey of Space and Time project, which is being run out of the Vera Rubin Observatory in Chile, is going to help astronomers track these space rocks from even farther away. Astronomers are going to create a detailed map of the sky and the regions where meteor showers are most likely to occur. It'll help them predict which asteroids might become a problem for Earth in the future, giving us plenty of time to prepare or come up with a plan. But even now, there are many space rocks that can potentially cause a lot of trouble to our planet. Let's look at some of them. Here's the asteroid Bennu. Astronomers discovered it in 1999. This carbon-rich rock is about 1,600 feet across. It's the height of the Shanghai World Financial Center. Didn't you know that? At the moment, this asteroid is the greatest threat to Earth that we're aware of. But don't panic yet. The collision won't happen for a long time. In fact, scientists calculate a 0.037% chance, which is about 1 in 2,700, of Bennu striking Earth on September 24, 2182. I won't be around then. If Bennu does hit our planet, the impact would release so much energy that it would be enough to cause massive destruction in a large region. But luckily, it wouldn't wipe out the entire planet. Still, if Bennu hit a city, the consequences could be catastrophic. NASA's OSIRIS-REx spacecraft has recently visited Bennu and returned with samples, so scientists are learning more about this asteroid all the time. The next asteroid is another one to keep an eye on. It was first discovered in 1950, but wasn't seen again until 2000. Right now, scientists say there's a very slim chance, 1 in 34,500, that it could hit Earth on March 16, 2880, 800 years into the future. So, am I worried? Nah. If it did strike, it would release so much energy it could lead to a global catastrophe, potentially wiping out humanity. Or not. Our next asteroid has been discovered only recently. It was spotted in October 2023. It has a very low chance of striking Earth on October 10, 2119. Man, they got it down to the day? Now, if it were to collide with our planet, the impact would release a lot of energy, which would have a devastating effect for large areas. So, while the arrival of this asteroid is a long shot, this asteroid is still worth keeping an eye on. Now, this asteroid is known as a lost asteroid because it hasn't been seen since 2007. No wonder, it has a very uncertain orbit, and we can't predict its movements. NASA says there's a tiny chance, about 1 in 10 million, that it could strike Earth on March 3, 2030. If it did, the energy released would be able to cause huge regional damage. Finally, we've got this space wanderer. On the one hand, it hasn't been seen since 1979. On the other, scientists believe that there's a very low chance that it could hit Earth on December 14, 2113. Mark your calendars. If it did, the impact would cause a lot of damage and devastation, but it would not lead to the end of humanity. Now, in any case, even though the chances of an asteroid hitting Earth are low, the consequences of such an event could be huge. That's why scientists are so focused on studying these space rocks and tracking their movements. Thanks to new technologies, we can track dangerous objects from farther away and catch them earlier. It can give us more time to react and come up with some effective solutions. Okay, it seems scientists have come across a strange object in space, and they're not sure if it's a star or a planet. What we do know is that it's located 1,400 light-years away from us, and it makes us question what we thought we knew about the universe. Let me explain the dilemma here. We can tell if something is a star or a planet by considering the object's mass or the amount of stuff it has. Stars have a lot of mass, which gives them strong gravity that squeezes them tightly. Squeezing creates high temperatures inside them, causing them to shine brightly. Planets have less mass, so their gravity is weaker. They don't experience the same squeezing or high temperatures as stars. Instead, planets shine because they reflect the light from their stars, like our beautiful Earth does with our Sun, too. And this weirdo falls somewhere in between, since we consider it a brown dwarf. It's a special type of big, gaseous protostars. Brown dwarfs are usually like Jupiter in terms of their atmosphere, but they are much larger in size, about 13 to 80 times. If a brown dwarf has more than 80 times the mass of Jupiter, it can start burning regular hydrogen, just like a star. That's what usually makes stars shine brightly. But normally, brown dwarfs are not as hot as stars. Their inability to burn hydrogen has even earned them the nickname of failed stars. They burn at around 4,000 degrees Fahrenheit, which is cooler than most stars. But this object defies the norm. Its temperature measures an incredible 13,900 degrees Fahrenheit. Now let's put that into perspective. The hottest day in history was reported to happen in Death Valley, California, more than 100 years ago, with a temperature of 134 degrees Fahrenheit. People back then must have felt like they were melting along with everything around them. Now imagine getting closer to the Sun, like taking a trip to Venus. Venus can reach insane temperatures of 860 degrees. It's not only about the distance, though. Mercury is the planet closest to the Sun, but it's still colder than Venus. Venus is extremely hot due to the greenhouse effect. Did you know that Venus could have been a delightful place to live a long time ago? Or at least be home to any form of life. But at some point, it started to trap carbon dioxide and eventually created this thick, smoggy oven that doesn't release heat. And that's why it's so hard to explore. The longest a probe managed to last on Venus was 2 hours. But hey, that's longer than I can do at work, and then I melt. So yeah, then you get to the Sun. Its surface burns at an incredible 9,930 degrees Fahrenheit. And what's fascinating is that this weird brown star we're talking about is hotter than that. I mean, it's not hotter than the Sun's core, whose temperatures go up to 27 million degrees, but it's still very impressive and unusual for a brown dwarf to be this hot. At least that's what everyone thought until they realized why it was happening. The brown dwarf is remarkably close to another star that falls into the category of white dwarfs. They're so close to each other that our mysterious star makes one orbit around its white dwarf friend in just 2.3 hours. Whew, how old we'd be over there! Since they're this close, they're tidally locked like our Moon and Earth. That means one side of this brown dwarf always faces the white dwarf, and the other side is forever in darkness. Because of all this, our brown dwarf is superheated on one side only. So its day side is what got us confused. While the temperature on the night side is what you would expect from a brown dwarf. But these extreme conditions won't last long. Such a hot temperature makes the molecules in the dwarf's atmosphere break apart into individual atoms. And while its molecules are falling apart, this brown dwarf is slowly disappearing. And if you think this brown dwarf is hot, what would you say about Eta Carinae? It's a star located about 7,500 light-years away from Earth, and it belongs to an elite group of stars we call luminous blue variables. One astronomer first noticed it in the 17th century, but back then, it was just a regular medium-bright star. Almost 200 years later, another astronomer was observing it. But this time, it was a very bright star, one of the brightest ones in the sky. A few years later, it reached the highest level of brightness in a big event called the Great Eruption. When it happened, the star could be easily seen in the night sky. It released so much light, as much as is emitted in a supernova explosion. It remained like that for a couple of years, which is not what usually happens with exploding stars. After the party reached its peak, the star decided it was time to leave. It's still hesitating though, so it's still alive but dimmer than before. There's a nebula around Eta Carinae too. It is a shell made of gas and dust that formed during the Great Eruption. It even blocks some of the star's light. Eta Carinae is a binary star system. That means there are two stars that orbit around each other. One component has a temperature of about 26,500 degrees, and the other 62,500 degrees. The main star in the Eta Carinae system, which is the more massive of the two, is 100 times heavier than our Sun. Because of its enormous mass, scientists predict that this star may eventually explode in a powerful event known as a supernova. But not for another several thousand years. So, by now, you might have already guessed what the hottest thing in the universe is. Ta-da! A supernova. The supernova is what tells us that the life of a star has ended. We're talking about the most powerful explosions in space. They happen when a star that's between 8 and 40 times more massive than our Sun flops. Its core can no longer create enough energy through a process called fusion, so the star can't even handle its own gravity. It's like a stellar burnout, too much work a star can't handle, and its core just collapses. During a supernova, the temperatures in the star's core can get 6,000 times higher than in the core of the Sun. Or sometimes, a specific type of star called a white dwarf suddenly restarts its nuclear fusion, and bam, you get a supernova again. Kepler's supernova happened at the beginning of the 17th century, and it was the last really big supernova event we directly observed from Earth. On average, supernovas in our galaxy happen 3 times every century. I mean, we got a smaller supernova in 1987 too, when a blue supergiant exploded in one of the Milky Way's satellite galaxies, which we know as the Large Magellanic Cloud. This explosion was so strong, people could even observe it with the unaided eye, even though it was incredibly far, 168,000 light-years away from our home planet. What a topic for summer days, huh? But check this out. We can also talk about the hottest thing people have ever created, made in a surprising place, Switzerland. Nah, we're not talking about a super hot chocolate. A group of scientists there created a subatomic soup called a quark-gluon plasma. In this experiment, the temperature got 250,000 times as hot as the sun's core. The purpose of this experiment was to recreate the conditions that existed shortly after the Big Bang, when the universe was still in a state of chaos. Okay, let's get even more extreme. In theory, things can get even hotter. Have you heard of the Planck temperature? It's an insanely hot temperature with numbers so high we can't even imagine. A supernova is like tepid tea compared to this madness. And who even knows what the matter does at these temperatures? Okay, I'm done. Now we take you back to your regular universe. Bye now.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the Sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The Sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the Sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the Sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky, because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket. The Sun is getting ready to flip as its magnetic poles are reversing. Similar to Earth, the Sun has a magnetic north and a magnetic south. But unlike Earth, the reversing process of the Sun's poles is more frequent and easier to predict. The next flipping is expected to take place this year between April and August. As apocalyptic as it might sound, you don't have to worry. If you're around 30, you've already experienced this phenomenon more than once as the Sun flips every 11 years. You probably didn't notice any changes back then because this process doesn't impact Earth's life so much. But this time, things might be a little different. On Earth, ocean currents are movements that play a crucial role in influencing both climate and weather by distributing heat from the equator to the poles. On the Sun, these currents are more like an ocean of plasma, but they not only transport heat but also carry electromagnetic energy. That happens because the Sun is a huge ball of hot and ionized gases that keep flowing inside its core. By fusing together hydrogen atoms and forming helium, our star releases a massive amount of energy, leading to these very heavy flowing electric currents. And whenever you have currents, you have magnetic fields. It's easier to understand if you think of that classic experiment with a wire and a nail that you probably conducted in elementary school. When electricity flows through a wire, it creates a magnetic field around the wire. So when you connect a wire to a battery and wrap it around a nail, the nail becomes a magnet. This is similar to how electric currents create magnetic fields on the Sun. This whole process, with the help of which the Sun generates its magnetic field, is called a dynamo. We can't observe it directly, but we can see its effects on the Sun's surface. When plasma and magnetism flows become unstable and intense, they manifest as sunspots. You know, those dark areas on the Sun's surface? Much about how the dynamo works remains a mystery. But scientists have learned something important after observing these sunspots for centuries. The dynamo process follows a pattern. About every decade, it reorganizes itself. The Sun's polar magnetic fields get weakened, eventually reaching zero, and then they return, but with the opposite polarity. Back in the 50s, researchers figured out that when sunspots start to ramp up and become more intense, it means the poles are gearing up for a reversal. And over the past few years, solar activity has been off the charts. We're talking about more solar flares, more electromagnetic radiation bursts, and more plasma blobs being ejected into space. It's like we're sitting in the front row at the solar system's most epic fireworks display. In fact, the Sun hasn't been this lively in probably 2 decades. Right now, experts think the polar fields are almost in sync and steadily weakening, inching closer and closer to zero. But we haven't reached the point of reversal yet. Although it might sound like the Sun flips its magnetic poles like clockwork every 11 years, the truth is that it's not as neat as it seems. This path can be bumpy, and some aspects of the phenomenon are still very hard to predict. Take the last solar cycle, for example. The Northern Hemisphere started its magnetic flip back in early June 2012, but then it kinda hit a snag and lingered around the neutral point until late 2014. Meanwhile, in the Southern Hemisphere, things were smoother, with the polarity switching over in mid-2013. This time around, the Sun is actually playing nice. Things seem to be running way smoother this cycle, with the poles transitioning more evenly. But here's the thing, reversal processes are never the same. That's what makes this phenomenon so interesting to observe. But at the same time, it's hard to predict how it'll affect us down here. Here on Earth, we don't have to worry too much about those intense sun explosions happening 93 million miles away. But if, and I emphasize if, a solar storm were to reach our planet, the main threat it would bring would probably be the disruption of communication satellites in space. However, things might be different in this cycle reversal happening in 2024 because the number of satellites has skyrocketed in recent years. For example, Elon Musk's Starlink system alone involves more than 4,000 of them. All these satellites, along with communication and GPS satellites, could be impacted or even destroyed by a powerful solar storm. Although the chances of a powerful solar storm hitting Earth are low, it's not impossible. Back in 1859, during the Carrington event, a storm occurred near the peak of the solar cycle, causing currents to surge through telegraph lines, sparking fires and disrupting messages worldwide. Earth fell silent as telegraph communications failed. Just imagine what a solar storm could do to our vast number of satellites today. It could affect everything we rely on daily, from space-based communication and navigation to weather forecasting services. The ground-level power distribution could also be affected. You can forget about watching YouTube or Brightside, because if such an event occurred today, it would cause an internet apocalypse, sending countless people and businesses offline. There's a prediction that says that if a Carrington-class event happened today, it would result in damages ranging from $0.6 to $2.6 trillion. And I'm talking about the United States alone. Fortunately for us, solar storms as intense as the Carrington event happen only once every 500 years or so. Bad news for communication satellites, but great news for Aurora watchers. During the Carrington event, dazzling auroras borealis lit up the sky as polar light shows stretched far beyond their usual ranges. The northern lights were spotted as far south as Cuba and Honolulu, Hawaii, while the southern lights were seen as far north as Santiago, Chile. For many people around the world, this was their first glimpse of the aurora, leaving them obsessed with the unusually bright skies. Some of them thought it was the end of the world, while others began their day early, thinking the sun had risen after hearing birds chirping and seeing the bright skies. Today, we know there's nothing strange about it, considering that the appearance of auroras at lower altitudes is one of the expected effects of the sun's magnetic pole reversal. Typically, these dazzling phenomena are found between 60 and 75 degrees latitude, but during the last magnetic pole reversal in 2013, intense auroras were observed below 50 degrees. Eyewitnesses describe these auroras as blood or deep crimson red, shining so brightly that you could read a newspaper in their light. It's important to study this phenomenon and not to fear it. The inversion of the magnetic poles on the sun is actually a great opportunity for scientists to better understand how our star works. Since many pieces are still missing in the whole dynamo situation, we're still not very good at predicting why some solar cycles are more intense than others, or when exactly a coronal mass ejection will erupt. But being able to predict that is becoming more and more necessary as we venture ourselves into space. The more people are out there beyond Earth, the more exposed they are to these strong solar storms. That's why the scientific community wants to know more precisely when a solar storm can cause damage to spacecraft and space stations. Plus, it would help meteorologists make progress in predicting weather, not only on Earth, but also in space. The whole point is to make space travel safer as the interest in crewed missions to the Moon and Mars grows every year. Another reason why it's important to learn more about the sun's pole inversion is to better understand how the mysterious interior of the sun works. That could actually help us figure out the aspects of other stars in the universe and maybe get closer to answering the ultimate question: why are we here?
On the 2nd of September 2023, India launched its first space probe to study the Sun. This solar mission is called Aditya L1. It's going to travel almost 1 million miles and join 4 other spacecraft that are currently circling a point in space known as Lagrange Point 1. But this Indian mission is different from the rest. How come? Experts call this mission a unique observatory, all because it combines instruments that can shed light on not one, but on 3 crucial questions. The first one is how stars like our Sun sustain their insanely hot outer layer. The next mystery that confuses scientists is how exactly the Sun's magnetic field produces such severe solar storms. And the last one is how the variations in the magnetic field of our star affect the atmosphere of our planet. Aditya L1 has 7 instruments that can help observe the layers of the Sun. For example, with the help of electromagnetic and particle detectors, the probe will examine the Sun's corona, which is the outer layer of the star. While doing it, The spacecraft will be hovering at a safe distance from the Sun, around 92 million miles. Researchers hope that the mission will be able to gather data on the properties of the corona and figure out what causes coronal mass ejections. Those are enormous bursts of electrons, ions, and magnetic fields. The probe is also expected to examine the Sun's lower atmosphere and the boundary between the atmosphere and the interior of the star. Everyone is waiting for the data from the mission with bated breath, especially from its Solar Ultraviolet Imaging Telescope. No wonder, it can help to study solar winds and the way they accelerate, as well as coronal heating. This telescope can also potentially provide images of the Sun's disk in the near ultraviolet for the first time ever. This disk is the outer visible layer of gas and dust surrounding the Sun. One of the mission's tasks is to help scientists figure out how the dynamics within the corona and the Sun's lower atmosphere drive space weather. You see, our star has a massive and pretty complex magnetic field which wanes and strengthens again, reaching its peak every 11 years or so. When it happens, the north and south poles of the field flip. The current cycle is predicted to reach its maximum in 2024 or 2025. It means that solar activity is going to keep rising in the next few years, making this period perfect for collecting data. There are 5 Lagrange points in space where the gravity between two bodies, in our case between the Sun and Earth, cancels out. It means that a spaceship can remain there with minimal use of fuel, and L1, which is the goal of Eta L1, offers a great view of the Sun as a benefit. The Indian space probe is going to join 4 other craft orbiting L1. The satellite is supposed to reach its orbit in the middle of January, and by the end of February, scientists hope to start getting regular reports. The probe is expected to send around 1,440 images per day to the ground station, where these pictures will be analyzed. Eta L1 isn't the only spacecraft exploring the Sun. Probably the most famous one is NASA's Parker Solar Probe. Its main goal is to touch the Sun. It's flying closer to the surface of our star than any other spacecraft before. Astronomers hope that this mission will revolutionize our understanding of the Sun. For one thing, the distance between the probe and the surface of our star is more than 7 times smaller than that between the Sun and any other spaceship. Plus, over 7 years of hard work, Parker is supposed to complete 24 orbits around the Sun, and at its closest approach, the spacecraft will hang out around 3.9 million miles away from the Sun, which in this situation is very close, and its speed will be about 430,000 miles per hour. If you moved at this same speed, you'd get from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe has its instruments protected from the Sun by a 4.5-inch thick carbon composite shield. It can withstand temperatures of around 2,500 degrees Fahrenheit. But what exactly does the probe do? It dives into the scorching atmosphere of our star, having to withstand insane heat and radiation just to give us a glimpse of what this atmosphere is like. In 2021, NASA announced that the probe had flown through the corona, the Sun's upper atmosphere. Parker managed to take samples of magnetic fields and particles there. It was the first time ever when a spaceship touched the Sun. The probe was designed to travel within 4 million miles of the surface of our star, tracing the flow of energy, studying the heating of the corona, and exploring the acceleration of the solar wind. Hopefully, we'll get the answers to a few long-standing questions, like why is the Sun's corona much hotter than the star's surface? What makes the solar wind accelerate? And what is the source of those high-energy solar particles? It's hard to believe, but we actually live in the Sun's atmosphere. At first sight, our star looks like a bright, self-contained sphere hanging out somewhere far away in space. But that visible edge is just the beginning. The Sun's hot corona reaches way past Earth, all the way to Pluto and even beyond. You can't normally see this corona. It's visible only during a total eclipse, but believe me, it's there. The corona has its own weather. Billion-ton coronal mass ejections occur there. High-energy radiation storms rage from the Sun's upper atmosphere. Relentless solar winds can reach a speed of 1,000,000 miles per hour, and every comet, asteroid, and even planet in the solar system is affected by those elements. The Sun still has a lot of surprises for us. For example, recently, NASA's Solar Dynamics Observatory has discovered a large coronal hole in the southern part of our star's outer atmosphere. The temperature there can reach millions of degrees Fahrenheit. Such giant coronal holes can have a dramatic impact on our planet. They mean that the Sun produces and sends off streams of gas that can easily reach Earth. This can result in geomagnetic storms, triggering disturbances in the atmosphere. At the same time, such solar flares also produce some of the most beautiful phenomena on Earth, the Aurora borealis. But since the flares affect our planet's magnetic field, they can have an impact on GPS mapping, satellite television signals, and even cell phone transmission. How bad it gets depends on the intensity of solar flares. Another rather frequent occurrence of this natural phenomenon is power grid outages. Luckily, Earth's magnetic field does a great job protecting us from solar flares. But sometimes, the flares are just too powerful to go unnoticed. Some of them can release 10 million times more energy than the most powerful volcanic eruptions. Within a few minutes, one flare can give out billions of tons of charged particles. Solar flares are also insanely high. Their temperatures can reach several million degrees Fahrenheit. Now, the following news may sound scary, but there are also super flares. In comparison to them, our Sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our Sun. It doesn't mean we're safe here on Earth. Even our middle-aged Sun knows how to produce super flares. But while young stars can have them once a week or even more often, for the Sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth. Or not.